Welcome to the CoSpace Robot family. Today, we will be introducing you to CoSpace Robot Rescue. CoSpace Robot is an official platform for both RoboCup Junior Rescue Simulation and RoboCup Asia-Pacific CoSpace Challenge. Please visit our website to find out more. In the CoSpace Rescue FirstSteps online challenge, participants have to develop and program appropriate strategies for a virtual autonomous robot to navigate and collect objects in a virtual world. The game will last for 5 minutes. The blue robot will be used to complete this challenge. The red robot will be removed. A team will gain points by collecting objects. Please refer to the slides for more details. For depositing one set of red, cyan, and blue objects at one go, you get 90 points. For depositing two sets of red, cyan, and blue objects at one go, you get 180 points. During the whole entire game, 3 relocations are allowed. The robot will be frozen for 10 seconds after each relocation. To successfully collect objects, the robot needs to use any one of the RGB sensors to detect the object. RGB stands for red, green, and blue. Stop for 3 seconds with LED flash. To successfully deposit objects, the robot needs to use both RGB sensors to detect the collection box. Stop for 3 seconds with LED on. After depositing, leave the deposit box automatically. For RCAP CoSpace Rescue FirstSteps, the system will divide the map into a 3x3 matrix with 9 sections. When the robot moves into each section, the robot's corresponding location information will be sent to the robot. This information can be used for planning purposes. The robot's current position on the screen is position X equals to 2 and position Y equals to 0. Hello, good job, we are almost there. Let's select CoSpace Rescue U12 in the subleague and choose CoSpace Rescue U12 map in the library. We'll run it to see if our computer is compatible with this software. While we're at it, let's also check and see the version of our software. It's always good to have the latest version. Awesome, it seems that our computer is compatible and our software is up to date. The activation window has just popped out, so please make sure you're connected to the internet and input your account number as well as your serial code, which is also your license number. So these will be given to you via email, so please make sure to check your email. And also please make sure when you put in your serial code there are no spaces in the front and at the back, because the serial code is case sensitive. And if you're having trouble with the software, you should right-click on the icon and click the Run as Administrator option. Let's start your first program. Launch CoSpace Rescue Simulator by double-clicking on the icon. Select the correct sub-league, content library, and competition map for the iCool challenge. Programming a robot consists of three elements: sensing, planning, and action. Let's take a look at the CoSpace Rescue virtual robot. It contains the following sensors: two color sensors to sense the floor RGB color. RGB stands for red, green, and blue. Three ultrasonic sensors to sense the obstacles on its front, left, and right. One compass sensor to sense the robot's orientation. For the robot's actuators, it contains two wheels and one LED for status indication. Participants have to plan and program strategies to control the robot so that it can collect more points. Click on the 3D environment. Now you can use the direction keys to manipulate to your preferred point of view. Click on the control panel and you will be able to control your robot using the direction keys on the computer keyboard. From the control panel, you will find live sensor data. If no program is loaded into the robot, you can use Minimap, virtual joystick controller, and keyboards to control the robot. When the program is running, all human operations such as pause, reset, Minimap, virtual joystick controller, and keyboards are disabled. What is the logic behind the robot's thinking process when it collects objects? The two color sensors mounted on the robot will let the robot know what kind of object is underneath it. And then the robot will take corresponding actions according to the sensor readings. So the first thing we need to do is to know the color of a particular spot on the map. We need to record the RGB readings of different objects. Red token's RGB reading is 255, 35, 35. The collection box is orange in color. Sign color RGB reading is 39, 255, 255. Black color RGB reading is 39, 39, 39. Traps are surrounded by a yellow boundary. If the robot goes over the inner blue part of the trap, it will lose all the objects it is currently carrying, so be very, very careful. Double-click on the AI button to enter the programming interface. On the top of the programming interface, you will find some file management buttons. First of all, you will need to create a new project. Click on the New Project button. Please remember to give this program a team ID, a team name, a project name. Remember, once team ID and team name are confirmed, they cannot be changed anymore. However, you can change the project name if you wish. As you can see, there are many statements in one program. Conditions are inputs from the environment. The priority is set by statement order. The higher the statement, the higher the priority. Actions are outputs to control the robot. A good navigation program can help the robot complete a more efficient search. We will start from a basic navigation program with 4 statements. The first statement should tell the robot to move forward if there is no obstacle. The second statement should tell the robot to turn right if there is an obstacle on the left. The third statement should tell the robot to turn left if there is an obstacle on the right. The fourth statement should control the robot appropriately if there is an obstacle ahead. Statement forward. There is no obstacle, so we'll keep the conditions empty. In this scenario, the robot should move forward. Statement turn right. There's an obstacle on the left. Let's set the condition as ultrasonic left is smaller than 12 and let the robot turn right. Statement turn left. There's an obstacle on the right. Let's set the condition as ultrasonic right is smaller than 12 and let the robot turn left. Statement front. There's an obstacle ahead. Let's set the condition as ultrasonic front is smaller than 12 and let the robot turn right. Great! We have completed our first program. Once you have completed programming, it is very important to save and build. The blue robot will be used to complete this challenge. The red robot will be removed. Now you can click on the blue Build and Test Project button to see how the robot will behave. If you wish to modify the program, click on the Stop button and go back to the AI panel to modify the program. If you stop the program manually, or if time is exhausted, the following dialog box will pop out. During the iCool challenge, you will need to save and submit the ICS file to the iCool challenge server. From our previous demonstration, we have learned how to navigate. Next, we will learn how to collect objects with color sensors. At the beginning of the video, we have manually moved our virtual robot over red, cyan, black, yellow, and orange colors on the map, and we have recorded the corresponding RGB reading from the color sensor. Because the robot has two color sensors, we need to calibrate them separately with different colors. In artificial intelligence, search techniques are universal problem-solving methods and are a very important component of AI. CoSpaceRobot Rescue FirstSteps is designed to allow users with no prior programming knowledge to learn search techniques in a 3D environment from scratch. In the CoSpace Rescue FirstSteps online challenge, participants have to develop and program appropriate strategies for a virtual autonomous robot to navigate and collect objects in a virtual world. After the statement name is defined, we will add conditions and actions to these statements. To successfully collect objects, the robot needs to use any one of the RGB sensors to detect the object. Stop for 3 seconds with LED flash. Set key action, find objects. Red token's RGB reading is 255, 35, 35. We'll set a range to include these values as conditions, and set actions accordingly. Stop for 3 seconds with LED flash. Set key action, find objects. We'll set a range to include these values as conditions, and set actions accordingly. Stop for 3 seconds with LED flash. Set key action, find objects. We will now calibrate the right color sensor for black objects and set an appropriate action. We will now calibrate the left color sensor for black objects and set an appropriate action. We will now calibrate the right color sensor for cyan objects and set an appropriate action. We will now calibrate the left color sensor for cyan objects and set an appropriate action. Let's build and test a program. Awesome, your robot has been successfully calibrated. If the robot is on a white surface or a regular zone, the red object is worth 10 points, cyan object is worth 15 points, and the black object is worth 20 points. If the robot is on a blue surface or a special zone, the red object is worth 20 points, cyan object is worth 30 points, and the black object is worth 40 points. If the robot falls into a trap, all objects that have been collected but not yet deposited in the object collection box will disappear. When crafting a strategy, please pay attention to both offense and defense. Be balanced. Use the color sensors to avoid the yellow warning line. We'll set a range to include these values as conditions. And set actions accordingly. We'll set a range to include these values as conditions. And set actions accordingly. The maximum number of objects the robot can carry at any one time is 6, so we can only pick up more objects after we deposit them into the orange collection box. Use both RGB sensors to detect the collection box. Stop for 3 seconds with LED on. Deposit 1 means moving backward after depositing. Deposit 2 means moving forward after depositing. Use both RGB sensors to detect the collection box. We'll set a range to include these values as conditions. And set actions accordingly. In iCool Challenge, you can load the DLL file and monitor the robot's performance in the control panel. When the program is running, all human operations such as pause, reset, minimap, virtual joystick controller, keyboards are disabled. Picking up a red object in the special area is worth 20 points. For every successful deposit, as a bonus, your points for that successful deposit will double. During the whole entire game, 3 relocations are allowed. The robot will be frozen for 10 seconds after each relocation. Second relocation. Third and final relocation. During a game, if you manually stop or pause the program, or if time is exhausted, the following dialog box will pop out. During the iCool challenge, you will need to save and submit the ICS file to the iCool challenge server. And off we go! In this demo game, we will minimize any manual intervention. Red robot uses marker to navigate into special zone. Red robot has a set of red, black, and cyan objects. It can generate a super object. Red robot is depositing. Blue robot is running into difficulties. System will reset it. Blue robot is searching in the blue special area. Any objects picked up in this area will double in value. Blue robot is depositing. Blue robot has overtaken red robot. Red robot is depositing. Red robot has overtaken blue robot. Blue robot is depositing. Oh no! Red robot has fallen into the trap. Points of the undeposited objects are reset and lost. Red robot is depositing. Blue robot is searching in the blue special area. Any objects picked up in this area will double in value. Blue robot is depositing. Red robot is depositing. Blue robot is depositing. One minute left. Blue robot is leading. Blue robot is depositing. Red robot is depositing. Blue robot wins this challenge. Congratulations!
Hello everyone, I am Heng Teng Yi from Singapore. I am participating in the Rescue FirstSteps U19 category. I've been doing robotics competitively for about 1.5 years now as part of my school's robotics club. In terms of RoboCup events, I've taken part in the RoboCup Singapore Open and the main RoboCup event in Sydney last year in the junior soccer lightweight category. My main role was working on hardware design, so designing, wiring and assembling the robots. On to my learning experience, CoSpaceRobot was basically my first time doing search problems since I mainly did hardware beforehand. In addition, to implement more complex strategies, I also had to learn how to program the robot in C, which was a language I had only dabbled in before. I am most interested in SG7114's video for Rescue U19 from the first sharing session. This video is not in my category, but I am planning to take part in the regular Rescue U19 category in the upcoming virtual RoboCup Asia-Pacific event. I would like to learn more about how he processed the image of the map and used it to improve his robot's pathfinding, since such strategies can be applied to any map rather than being specific to a certain map, so it seems useful when preparing for future attempts at CoSpace Rescue. To share my knowledge on robotics and AI with others, well, I'm still learning, but I post my robotics projects on my GitHub, although not very well documented, and of course I help my fellow clubmates and juniors when preparing for future competitions such as this one. Now for my strategy, I will start with square targeting. In my strategy, the robot has squares it wants to travel to, and by squares I mean one of the 3x3 coordinates. But how does it know how to travel there? Firstly, there is a target angle that we want the robot to move forward at. For example, if we want the robot to move one square to the left, then we will want the compass to read 90 degrees. Using the compass reading and proportional control, the steering rate of the robot is adjusted to rotate the robot towards this target angle. But when it is moving towards the square, we also want to make sure it does not run into walls and obstacles. To handle this, there is a separate steering rate for wall avoidance when any of the ultrasonic sensors have a reading below 25 to rotate the robot out of harm's way. And the two steering rates are merged such that the lower the ultrasonic readings, the higher the steering rate for wall avoidance and lower the steering rate for square targeting. Moving on to some of the robot's basic functions, there is detecting objects to pick them up and detecting the deposit zone to deposit them. The simplest way to detect objects and deposits is to check if the color code of the landmark matches the color sensor readings. But to increase sensitivity, the code actually checks if the readings are just close enough to the color codes, with a leeway of around ± 25. This lets the robot get more objects faster. In addition, to avoid losing objects, there is trap avoidance. To prevent the robot from running into the traps, it slows down to 80% speed when it is facing them, so the robot can see the warning in time before running into the trap. Once it sees the warning, it will reverse and rotate out of the way. I will go into the movement strategy now, one key feature of which is fluid movement. So one common strategy is to use the markers and position coordinates to code a fixed path for the robot. For example, it could travel to the top left square, then the middle left square, then the center square, and deposit at the top. This approach is limited in that the objects spawn in random areas, but the robot usually covers a small area due to its fixed path and retreads previously covered ground as well. Hence, to cover more area and collect more objects, the robot does not follow a fixed path and travels wherever it wants to, turning only to avoid walls or target specific colors. This brings me to another main part of the strategy, which is for the robot to target specific squares with specific colors to get 2 objects of each color and gain 180 bonus points per deposit. So for example, if the robot has 2 red and 2 black objects, it only needs cyan objects, so it travels to the center and bottom right squares since those are where the cyan objects spawn, and avoids the rest. And once it's in those squares, it resumes fluid movement. Other than getting combos, the robot also avoids traveling to the bottom squares. The bottom left square has no object spawning in it, and all the bottom squares are very close to traps. Hence, the robot immediately turns around when in the bottom left square, and does not actively target the other 2 squares, although it will stay in those squares if it travels into them by chance, since they still spawn objects. In addition, since the bottom is dangerous now, the robot deposits at the top middle square. So the entire strategy is this loop of collecting 2 objects of each color and depositing at the top. In terms of problems I faced, the main issue was mainly dealing with syntax errors in C, which are minor enough not to show up when compiling, but can cause the code to malfunction. For example, multiplying an integer and a float gives an integer result, and using 1 equal sign instead of 2 equal signs can give incorrect results in if statements. If you've done C, you'll probably recognize these issues, and they are quite minor, but since my program was rather long, it sometimes took a lot of time to catch those bugs in the code. And throughout the challenge, my main method to improve my scores was to find ways to use the map to my advantage without coding a fixed path. So that's why my robot strategy made use of the traps positions, and where each color would spawn, and also the locations of the obstacles. Another thing to note is how useful the 180 point bonus is. If the robot is able to get 2 objects of each color and deposit, it could score higher even if the opponent collected much more objects. So that's why my strategy always aimed for the bonus. Okay, that's it. Thank you for listening.